Okay, guys, so I gave you the different ways you could see it expressed this way, but I also want to add in the other way you could see this written using interval notation. Okay, so if this is our answer, or any of these are answers, then we know with when it says or equal to, we're going to give it a bracket, right? So I'll go ahead and list my numbers. It's going to go from -2 to 6. We know that. Since -2, x is greater than or equal to, we're going to put a bracket, right? And then since x is less than or equal to 6, we're going to put a bracket around that. So this is how it could be expressed in interval notation. Okay, and then to express this one in interval notation, it's slightly differently because the shaded areas are on the outside, right? So we use what we call a union. So we would say, since this is going to go all the way on forever and ever, all the way to negative infinity, right? And this direction is going to go on and on and on forever to positive infinity. So these are our two, sections that we're going to have. We would have from negative infinity up to -11. Okay. Your infinities and negative infinities always get a parentheses. Oops. Always get a parentheses. And then since this can actually equal -11, see, it's just m is less than -11. It can't be equal to. Then we put a parentheses. And then we're going to put a u for a union because we have another section, right? It's not just this, we also have this section that's shaded as well. So this section runs from 1 to infinity. So I'm writing a little crooked here. All right, from 1 to infinity. Since 1 is an open circle, 1 doesn't have the or equal to, right? M has to be greater than 1, can't be or equal to 1. Then we put a parentheses around 1. And for your infinity symbol, it always gets a parentheses. So this would be another way we could express the answer. A couple more examples to look at real quick. Okay, so and inequalities, so we're going to run from our smallest number to our largest. So out of 3 and -4, and -4 is our smallest number. I'll write it off to the side. So we'll say -4, comma 3. Since -4 has the or equal to, it gets a bracket. 3 is also or equal to, so we're also going to give 3 a bracket. All right. The next one's an and. Ands are going to be written like this. Ors are where we're going to have the union, right? We're going to put the u. So and is going to run from -1 to -6. The smaller one out of -1 and -6 is the -6 because it's further away from 0, right? It's further to left, it's smaller to left on your number line. And our larger one of the two is -1. And -6 has an greater than or equal to, so -6 would get the bracket. And then x is less than -1. It doesn't have the or equal to, so we're just going to put the parentheses. Okay? Here we have an or. So x is any value greater than 9, or x is any value less than 4. Okay? If you need to put this on a number line, that would help you. Go ahead. Okay? So my number line would look something like this. We have 4, we have 9. So we want any x value that's less than 4. Less than, we're going to the left. And any x value that's greater than 9. Neither of these had an or equal to, so I don't shade in either of the circles. I leave them as open circles. So we know this is going to keep going all the way forever and ever, all the way to negative infinity. And then this one's going to go right forever, greater and greater, all the way to infinity. So our answer would be negative infinity to 4. Infinity always gets a parentheses, and the open circle always gets a parentheses. Union kind of like combines the two, like this one plus whatever we put over here. So we're going from 9 with a parentheses because it's an open circle all the way to infinity with a parentheses, because infinity just keeps going on and on and on and on forever. You can never actually reach it or touch it, right? So it gets an open circle. A parentheses. Sorry, guys. And then for this example, let's change it up. Let's add a or equal to on this inequality. All right, so same thing. I'll just draw my number line over here. 0 and 6. So we want any x value less than 0. And then we want any x value greater than or equal to 6. Okay, so for our answer, once again, this is going to the left forever to negative infinity, and this one's going to the right forever for infinity. So our answer would be negative infinity with a parentheses all the way to 0, open circle, so parentheses. Union, we would have 6 with a bracket. Since it has a closed circle, it can actually equal 6. So here is a bracket all the way to infinity with a parentheses. Just a little bonus note on your assignment for today, you will see a question that looks like this, or a few questions similar to this, where it says choose the problem that has the following solution. So it's giving you the answer already. It wants you to figure out which of these would give you this is your answer. So you may have to solve a few of them before you actually find the right one that gives you this is your answer. Okay, so you may have to solve this first one to get your two answers and see if your answers match up with negative 9 and 6, right? You would have to do this one, maybe this one, and this one. We could pick a few random ones. Say we chose C because C looks simple, right? If I solve this off to the side, absolute value of x plus 2 is less than or equal to 3. Your absolute value is already isolated. You can see this equation, since it's written as one inequality statement with the two inequalities, it is an and inequality, right? So with and inequalities, we would need our absolute values to be less than, which we do have here. If you look at B, don't be tricked by this inequality and think this is an or. You have a negative 2 being multiplied out front. We'll get there in 1 second. All right, so for this inequality, we'd have our two equations. X plus 2 would be less than or equal to 3. And then we'd also have x plus 2 is greater than or equal to a negative 3. Running off the page. Okay. So we would do minus 2 on both sides, and we would get x is less than or equal to 1. That's not one of my answers, so I can stop there, and I know my answer choice C is incorrect, right? Let's look at B real quick because that's an interesting one. If I have negative 2 times the absolute value of 2x plus 3 plus 14 is greater than or equal to negative 16, let's look at getting this by itself. So I'd subtract a 14 from both sides. Okay, so I'd have negative 2 times the absolute value of 2x plus 3 would be greater than or equal to a negative 30. And then to cancel out this negative 2 that's being multiplied, because there's nothing in between your 2 and your absolute value, so you know it's being multiplied. So we're going to divide by a negative 2. And then when you divide by a negative, remember that flips our inequality. So now it is still facing the same way as the others, the way we need it to face to be an and inequality statement, right? So value of 2x plus 3. And I'm running out of room, but our 2 two inequalities would be 2x plus 3 is less than or equal to 15. And we'll do the second one over here. And then we'd also have 2x plus 3. We'd flip our sign to be greater than or equal to, and we'd change positive 15 to be a negative 15. So let's solve them. Minus 3 on both sides. So we get 2x is greater than or equal to a negative 18. Divide both sides by 2, and we would get that x is greater than or equal to a negative 9. That is what we have up here. X is greater than, right, if we flip this, greater than or equal to a negative 9. So we're good there. Let's try this other one. Minus 3 from both sides. So we get 2x is less than or equal to 12. Divide both sides by 2, and you get x is less than or equal to 6, which is what we have here. So B would be the answer.